think we're talking about reinventing HPC because there might be that perception that because of AI, HPC is something of the past. I think people tend to forget that AI in the end is just another high performance computing workload. It's the next generation workload. We're going to be able to tackle problems a different way and use the progress of AI and the ability of lower data types to effectively start expanding and having a new view of some of these things.
On AI, it's just clear that there's such a deficit in compute power. Your HPC was created because it was realized that there had been a chronic underinvestment in supercomputers in Europe. And we've now been spending time building them and making ready, and they've become operational. And then at the same time, this whole new user community comes and also wishes to have access. So it has just resulted in a shortage of capacity, which for your HPC is a luxury problem. We now need to build more, which is part of the fun. But of course, for the users, who are queuing up to get access to our supercomputers, it's annoying for both communities. The AI community who did not traditionally use the supercomputer, and therefore the concept of having to wait is, annoying. And then you have the scientists who have been queuing up and all of a sudden see others in the queue. So we will hopefully install these machines with teams around them that are especially good at helping the AI community.
People have been talking a long time about the convergence of HPC, AI and quantum. For us, it's a reality now. Our customers are really asking us, how can they integrate quantum and HPC? How can AI and HPC work together? How can we deliver those kind of solutions to clients to give that advantage?
The promise of quantum is it will let us do problems that are really so hard that we don't even contemplate solving them, that we find other approaches, we find other approximations, and it will change the way we think about what's doable. I think that's what's exciting about it. It's important to note that quantum machines are terrible at a lot of things, but they're fantastic at some things that are so hard we don't even do them now, and I think that's what's exciting.
This event started as a high-performance computing event, and I'm attending this event since the end of the 90s. Now the trend goes in the artificial intelligence, so the AI market. Nevertheless, the basis of the data that is generated out of simulations, so the high-performance computing is still here, and definitively the convergence of the two worlds, high-performance computing and artificial intelligence, is the one that bring the humanity to be able to solve big problems having our technology. Right.
From a climate improvement perspective, there is so much we still can do with artificial intelligence. We have such huge amounts of data available already of what the currents are in our oceans, what the airflow is in the sky, what the influence of the temperature of the seawater is on the climate changes that we're seeing. So we're working with a couple of those research institutions that are starting to engage on AI now, and that's starting to develop AI algorithms to better utilize the data that they have and to complement the data that they have to create better predictions for the directions we need to go into on a short term and on a long term.
We follow the trends with digital twins. Digital twins is actually a technology that uses HPC and computing power to simulate the entire Earth, and the goal is to actually have even more accurate weather prediction, especially when it comes to extreme phenomena and seeing the effects of climate change. So I think this is very useful, not only for safeguarding life, but to make decisions also for sustainability, how to build a society, how to build our economy and technologies to be more climate sustainable.
It's not just about those people with physics degrees or math degrees, it's really about humanity. When I did talk to my children about becoming part of high performance computing, and I would tell you in their high school years, they were like, oh Mom, that's boring. They would go and see the computers and they'd be like, nothing very exciting. But my daughter is a computer scientist, and she ended up taking high performance computing classes in her master's, and she got very excited about the impact it could have on society. I do think that's where we're going to get the excitement from youth. It's not just about doing the programming or building the boxes, it is about what they do. and how they can really have the impact they want on the world.
This is my first conference, so I am here to present my first poster on my latest Boltzmann method in quantum. My technology is just a baby step in the research. It's like a fluid dynamics, so you can see the microscopic or mesoscopic level of particles behavior. So it can be used in aerodynamics or air systems or any water system. So yeah.
If I had the ability to perform magic and solve a problem in the current world, it would be to make drug design easy, because it is such an expensive endeavor. It takes it can be up to 12 years just to develop a drug and bring it onto market. I wish it was a much easier process just to treat people in general, and also make drugs a lot less expensive than they currently are.
From my perspective, so as someone whose kind of early career is, the way we are using HPC is changing. So it used to be we would have worked a lot with MPI, CUDA, OpenMP, but now we're working a lot more in machine learning. There's a lot more quantum. The demographics of our center are changing. We've got more quantum people, we've got more deep learning experts, which is very exciting for me as someone who's early in my career, learning more, learning new skills. In the future, I hope HPC can make the world a better place in a lot of ways.